here's another example. So the number of bacteria in a culture grows at an exponential growth rate of 139% per hour. So what is the doubling time for this bacteria? So there's a lot of missing information here, but you can still solve this problem. So we know that P of t is equal to PERT. Now, we don't know a lot of things. The only thing that we really know is the exponential growth rate, which is 139%. Now we want this as a decimal, so this is going to be 1.39 as a decimal. Now we're looking for the doubling time. When is the bacteria going to double? I don't know what P is, and I also don't know what P of t is. But if I know what P is, then I actually know what P of t is, because this is going to be 2 times P. Okay, so if my initial was P, then when it doubles, it's going to be 2 times P. So I don't really care what P is. Okay, and you'll see why. Then you have E. R is just going to be 1.39, and then T. Now, see what happens. Because we have P on both sides, what can happen is that the P's are just going to go away. So I'm going to have 2 is equal to e to the 1.39 times t. Now I can just solve for t. So I can apply a natural log to both sides. So I can take ln and ln to both sides. Okay, so what I'm going to be left with here is a 2 and e to the 1.39 times t. Okay, so I'm going to move this 1.39 t all over. So I'm going to have ln of 2 is equal to 1.39 t times ln of e, which is just 1. Okay, now I need to solve for this. All I got to do is just divide by 1.39 to both sides. So I'm going to have t is approximately equal to whatever that is. So I'm going to have ln of 2 divided by 1.39. This is going to give me about 0.498. Okay, if I wanted to round this a little bit more, it will be about 0.5, which is basically half an hour. Okay, so in half an hour, I will have double the bacteria that I had from the initially. Okay.